And the plan is we will be discussing the two essay question papers, right? And I'll try my best to finish it by 6:30 if possible. And I will let you know what is the plan next, whether we are going to discuss the last day paper 1 or whether we are going to do the paper, right? But anyhow, this is first priority. Okay, so let's move on with the discussion. Right. Add the missing state symbols to the chemical equation. Your answer going to be. Right, so this is magnesium carbonate solid. How do you know it's solid? Carbonates are insoluble except for group 1 and ammonium. Then right? Plus 2HCl aqueous. Right? How do you know HCl aqueous? Acids are soluble in water. Right? Acids are soluble in water. And that will give you magnesium chloride aqueous anyway, they have given it, right? And water, H2O liquid, you know that carbon dioxide is a gas. So if all physical states given are correct, you get 1 mark. All right, you get 1. And magnesium, iron, I can write it here, over here, +2. We all know because it's in group 2, then +2. Chloride is always -1. So you just put minus or -1, doesn't matter. Right? Put your answers. Complete the dot and cross diagram to show the electron arrangement in molecules of carbon dioxide. What you can do is you can write down the answers in the assignment and the papers are available, right? And oxygen is 2, 6. So oxygen needs 2, right? Okay, almost everyone has joined. Okay.
So
You want to join?
B part, couldn't you complete the dot and cross diagram?
Sorry?
B part, complete the dot and cross diagram.
Have they said that? Complete the dot and cross diagram will show the what? Yes. We show the yes. I haven't read this part. Dot and cross diagram. I just put the charges, right? That means I have to put the magnesium. Magnesium has 288 configuration. As a result, I have to put 2 more shells, right? That's why 3 marks. That's why 3 marks. Okay, so I can depending on the stuff. So this it was 2882. So you remove 2, so then you need to have 288. Very good. Okay, it's 282. Therefore, you need to have only 1 electron shell, right? Chlorine is 287, right? So it must have gained 1 electron. Then you will get electrons, but I can't use crosses. Why can't I use crosses? Because they have given dots, but I have to use a dot to show the extra electron came from the magnesium atom. Because magnesium gave 1 electron to chlorine, right? That should be shown in cross, right? And magnesium with 2, like last 2 electrons were given to the chlorine atom. All right, right? Chlorine was 287 and it needed 1, and that 1 was taken from magnesium. Okay, Right, so then here we have dot and cross and 6 dots. All right, so this is ionic because magnesium wanted to remove electrons, right? And the chlorine wanted to get electrons. But in this case, oxygen needs 2, carbon is 2, 4. So carbon needs 4, right? It needs 4. Oxygen needs 2, carbon needs 4. So pair share policy. If oxygen needs 2, oxygen has to share 2. Then carbon has to share 2 as well. So complete the dot and cross diagram, right, to show the electron arrangement of molecule of carbon dioxide. So oxygen donated 2 and carbon donated 2. Oxygen has 4 remaining. Now you are showing the last shell electrons only. All right. And now this side also oxygen is donating 2, right? And carbon will be donating 2. Then oxygens have 4 more electrons because it has altogether 6 electrons, right? And you put like this. Now you have to check whether you have put carbon's electrons. Carbon has 4, right? 4 crosses. So you have put 4 crosses and carbon has also got 8. Right, so this is the dot and cross diagram of carbon dioxide, right? Okay, I assume online students can hear me clearly. For a short period of time, I am on mobile hotspot. Just in case if you can't hear me, let me know. Right, next one. This is the page numbers. There was a page number mixed up in the page 3. Hello? Yeah, you can ask question, yes?
So today you are doing acid base salt dissection, right? Revision paper.
In the MCQ paper, yes. Before that, I am explaining the revision series 3 and 4 essay questions, right? We have clearly communicated that to you, right, in the WhatsApp. So, okay. Calculate the number of moles of HCl. Now, this is so easy. Why? The volume is given, the concentration is given. So, you write N equals CV. You don't need to like think a lot in this case, right? So then concentration is 0.4, volume is 25 into 10 to the power minus 3. Now you have to write the answers while I'm doing it because I'm not going to give a lot of time after this, right? So when you multiply this, you get 0.01 moles. Am I correct? Right? You have to help me for the calculations because I'm doing mental calculations. The method of focus focus right? I'm discussing the revision series 3 essay paper. Right, determine the number of moles of carbon dioxide given O. So you can see HCl and carbon dioxide. HCl and carbon dioxide, the ratio is 2:1. Right? And HCl moles 0.01, they are asking carbon dioxide moles, cross multiply, you get X equals 0.005 moles, right? So then, now these questions are easy questions. Probably these type of questions can appear in your semester examination, right? Along with the percentage questions as well, right? Calculate the volume. So then volume of gas, you know, N equals V over 24, right? So today I'm like trying to maintain kind of a steady speed of explanation to make sure that you grasp things, right? So then the volume will be 24 into 0.005, right? I assume it's from 0.1 to BN cube.
Yeah.
Right. So those are the answers.
CM3.
They asked the question, yeah, they have asked the answer in CM cube, then I have to multiply this by 1000. Therefore, the answer is 120 cm cube, right? 120. Anyway, I'll give just 1 minute for each page for the physical students because they won't get a chance to see the answers. By the way, as much as possible, please join the class physically, right? But after informing us, okay? Come with the internet. Yeah.
So for this dotted thing, the graphs, the diagram, how many marks you will get?
ඒ වෙලාවේ මේව mark කරගන්න 2 marks, shared electrons 1 mark, unshared electrons 1 mark. Right. Identify the element which is in group 7, period 4. So you have to go to the period 4, the period 4, the horizontal one, and group 7, the vertical one. What is it? Is it bromine or iodine?
It's not 7, it's 6.
6. Something really wrong today, right? Okay, group 6, right? So you look at group 6 and period number 4. What is it?
Selenium.
Selenium, right? So the answer is selenium. Okay, calcium is in group 2. I'm worried about the electricity going at 6 o'clock. That's right? Okay, calcium is in group 2 and chlorine is in group 7 of the periodic table. Right? Explain in terms of number of outer shell electrons and electron transfer, how calcium atoms and chlorine atoms form ions, right? So then say in terms of number of outer shell electrons and electron transfer. So you can say calcium has 2, 8, 8, 2 electron configuration, right? Because it's in the group 2 and its atomic number is 20. And then chlorine, we just said 2, 8, 7, right? And then you're going to say calcium removes 2 electrons in order to obtain the stability. And so it forms. Now, I'm not writing the whole paragraph answer. I'm writing the points that the marks are located, right? So it forms 2 plus ion, right? And chlorine, each atom gains 1 electron. Each atom gains 1 electron. So then it forms -1 ion. They ask explain in terms of outer shell electrons. So you can either write the electron configuration or just say the last shell electrons. Calcium has 2 and chlorine has 7, right? Okay. And then calcium removes 2, chlorine gains 1, and give the formula of ion form. So then not only the charge, you have to tell the formula of ion. Give the formula of ion chloride. So the marks allocation saying they are in the particular groups. I mean, not groups. They're having 2 electrons and 7 electrons in the last shell. 1 mark, and then calcium removes 2, chlorine each gain 1, and charge of each ion. Right. So that's how the 5 marks are allocated. Right. Clear. Right, next one. Group 5 chlorides are covalent molecules, right? So you, from your mind, you need to go to the structures of compounds. We have giant structures, right? We have simple covalent, simple structures. In giant, you have giant covalent. I'm just like giving you some short note. I thought of like giving you some short note hints within, during the discussion also, but I'll be improving the revision class even further. next month, the setup of the revision class is going to change, right? I'm planning to give you some kind of a short note materials, right? Not everything type, right? Before whatever the topic that I'm going to give the questions in, I'll give you a small short note material and I'll discuss that and then give the questions to improve your performance, right? So we are planning so many things. Okay, simple, you have simple molecules, and also you have simple atoms. Let me give you example. Giant covalent is like silicon dioxide, right? Diamond, right? So I assume these kind of revision will help you to perform well. Graphite, giant ionic is like sodium chloride, giant metallic is like iron, zinc and stuff. Simple molecular means like oxygen, carbon dioxide, nitrogen. Atoms means helium, neon, argon. These are the simple atomic substances. So the simple atomic ones have very low melting points and boiling points, right? Whereas giants have high melting points and boiling points. Is that clear? So then like these kind of helping, like study friendly notes I will give you so that you can get. I'll just give you like about a little bit of structures, right? And NCl 377, 71 and arsenic chloride 130. Antimony chloride is 283. So you have to predict the boiling point of PCl3 obviously is going to increase. So anything like when you look at the difference here is 150, but you can't have 150 difference there because it's only just 130. So then I prefer something around what? 100, no? Because 71, 130, mathematics 100, right? So we just add them and divide it by 2. So then 71 plus 130 to 101 divided by 2. So that's a nice way of getting kind of an average value. Suggest the approximate boiling point. We did it, right? Approximate and explain the trend of boiling point in terms of attractive forces. No need to tell much, right? You can't do this. You can't do this in detail because if you are going to do this in detail, it's like an A-level question. Only thing you have to say, explain the trend. First of all, you say it increases, right? It increases, right? Down the groove. Right, increases down the groove, right? And then only thing you can tell in all levels, the intermolecular attractions become stronger. That's all you can say, right? Their intermolecular attractions, or attractive forces, intermolecular attractive forces become stronger, right? Stronger down the groove. That's all you can tell. You can't tell much things in all levels in terms of these intermolecular attractions. I think we have added every one of you into the Microsoft Teams. If not, let us know today, right? So that if you miss anything to write, they will be available in the chat, right? Okay, so calculate the mass of lithium fluoride needed to react with mass of lithium phosphochloride something. They have given the procedure as well. So it's going to be easy. Calculate the number of moles of this LiPF3. What you have to do, the mass is given. So you apply M over capital M. So basically they have given only 1 mark, but normally for first thing they usually give 2 marks if this wasn't given, but it is given, right? Because finding molecular mass or the molar mass is also 1 mark, right? So this will give you 0.02, right? 0.02. So that's the moles of this, right? We found the moles of this. So they ask moles of lithium fluoride. So when you check that, you have 1:6 ratio, right? So then you write LiPF6 to lithium fluoride is 1:6. Therefore, 0.022x. So you cross multiply, you get 0.12 moles, right? And then you apply N equals M over capital M. And moles will be 0.12. Mass, we don't know the molar mass, you need to calculate. What's the molar mass? 26. So then M is equal 0.12 into 26. So you get something 2.3.12. 3.12. So then 1 mark for each calculation because only 3 marks there. Clear, right? And lithium fluoride has ionic bonding. Let me remind those who still can't do these things. Remember this, lithium is a metal, right? Fluorine is a non-metal. Therefore, it should be an ionic bond, right? So what is an ionic bond? Very good question, right? You must say it is strong electrostatic attractions. Strong electrostatic attractions between oppositely charged ions. Or you can say between cations and anions. So cations and anions, 1 mark, right? Strong electrostatic attraction is 1 mark. This is the best possible definition you can give. Sometimes you might have written that's the bond between metal and non-metal. I told you don't write that. Yes, we guess it from that. But metal forms cations, non-metal forms anions. The real bond is between the two opposite charge ions, right? Okay, give 2 physical properties of ionic compounds. You can write many, right? But most preferably you can write high melting point, right? And also conduct electricity in molten or aqueous states. Then lamai, I know some of you are in the mentality of that monthly test experience that you got some questions in the revision class which came in the monthly test, right? එහෙම වෙන්නේ නෑ හැමතිස්සෙම. හරිද? ඒකින්ද හැමතිස්සෙම මේකේ concept එකයි ඔළුවට ගන්න ඕනේ. Because definitely you will get these type of questions. No doubt. The ionic bonds, covalent bonds, these structure property relationships, they will definitely be there. There is no doubt. But don't expect same thing to come so that you can buy heart and go. That never happens. Yes. Yeah, thank you. 5:55. Online students, just give me like five minutes. Patakila, give me 5 minutes. I want to shift the system into backup power because the current is going to go. So today I'm taking all precautions because Monday class we had to face a terrible experience. In the middle of the class, we Varuna battery power. I charge and get time में काट देता.
For the ionic bond, the description I know the same thing. Exactly.
Yeah, that's the exact definition I gave you in the book as well, right? ඒකේ විදියට මතක තියාගන්න ඕනේ.
That's an antibiotic member in a metal and non-metal group.
Anion cation dividend.
One is oppositely charged.
So you can say oppositely charged ions formed by metal atoms and non-metal atoms. But the problem is you can find the ionic bonds not only between metal and non-metals. Right? ammonium chloride. Ammonium ion and chloride ion. You don't have metal. That's why some of the definitions we are very careful. When we give you the definitions, we are very careful. We are thinking your further knowledge. Like then there a definition A-level definition complete to not pay. Chemistry. That's why we are very careful. Like that's why we are not giving you these shortcut methods and all these things maybe blindly. We give like after big screening process. Yeah.
Sir, in electrolysis, sir, we learned that molten ionic solutions, ions can't move, so they can only move in aqueous states. Possibly fixed in position.
Nishika, can you ask question please again?
Sir, in electrolysis, there was this thing where in molten solutions, the positive ions, they're fixed in position, so they can't move. So
Molten, no. Molten, both ions can move. In molten and aqueous form, both ions can move without any problem. Okay.
Okay, sir.
Sir,
Nithilan, the question.
sir, in ionic equation, sir, if we just say conducts electricity, it's wrong, right?
It's wrong. You have to give the which state it conducts electricity.
Yes, sir.
No, strong, not an answer because it's brittle. Ionic compounds are brittle. You can write some of them are soluble in water. You can write some of them are soluble in water. Ionic compound properties, some are soluble in water. That is acceptable. Also, you can write most of them are solids at room temperature. That's also possible because actually almost all of the ionic compounds are solids at room. Okay, let's answer. Not even exits. All right, so we are back in action. Few minutes we are in down. Oh. All right, so this is the question now we have to do. Okay, question number 3, and we are in revision series 3. Brush. Price alteration. Right. Calculate the maximum mass of barium sulfate that could be made. 2 marks. So it's not like a question that you did in the previous one. You have to follow the steps and then find, right? So it's kind of an advance. Put your videos on and join the class, Lamai. Right? Only 3 people I can see so far. So they have given barium nitrate. Now you are finding where is barium nitrate here. Don't worry, barium ions are coming from barium nitrate. So find the moles of barium nitrate. Right? So the first thing you are going to find moles of barium nitrates, moles of barium ions using barium nitrate. So you have to figure out volume given, concentration given. Now this is a very good practice. Quickly marking what data is given, VO, CO, right? That is a really good practice. Okay, so then you straight away figure out, you know what information is there. Okay, let's say level. 20 divided by 1000, right? So then what's the answer over here? 0.0055. How 0 kakena?
0.01.
Ah, yes.
Yeah.
My bad, mom. I'm bad in maths now, so 0.00. 0 limit.
0.011.
0.1. I'm bad in maths, right? So this is the moles of barium ions. So they are asking maximum mass of barium sulfate. So we found barium moles. 0.011. Now we jump into barium sulfate. That's 1:1. Right? Then may question it. It is not a question which gave you the steps. You have to think about the steps. Okay, Sarah? Yeah. Okay. So then the moles of barium sulfate will be the same, 0.011. But still they don't ask the moles of barium sulfate. They are asking the mass of barium sulfate. Therefore, you are going to apply N equals M over capital M. 0.011 M. Capital M will be 233. So then you can see sometimes they give data. Okay, kindly tell me before I make a mistake, something like 2.563. What's the value? 2.563 grams. 563 grams. But it's a nice question. It's about the percentage yield calculation. They didn't put you in trouble a lot. Second step only, they ask the percentage yield, right? So-
Can I answer one more component?
One more compare. One. Percentage is equal to experimental yield divided by theoretical yield. May theoretical yield. That's a maximum yield possible, right? Into 100. So then it will become 1.92 grams divided by 2.563 into 100. Yeah, 70 gana ke 74.9 or even 75 is all right. Okay, 75. Okay, just one minute. On the end of calculations, you have marked or right. Right. 1 minute is one. So chlorine reacts with sodium hydroxide. That's again 3-mark question. Right. So we have chosen questions in a very strategic way. We gave you easy question in the question 2. Now question 3, little more advanced. Right. Measured at room temperature and pressure is passed into 38 cm cube of sodium hydroxide. Show by calculation which reactant is in excess. Right? What's the golden rule of calculations in reagent in excess and the limiting reagent? Ignore one. Very good. Right? What you have to do now, look at this. The data for both reactants given. Right? So then that makes us confusing because you can find the moles of both. And then what to use the stoichiometry is confused. So we forget one. Let's forget sodium hydroxide. Assume we don't know sodium hydroxide. That's the way I ask you to do this. Huh? So we are going to find moles of chlorine. Moles of chlorine. So moles of chlorine will be N equals V over 24. I don't have to like emphasize again and again. So this is 144 divided by 1000 divided by 24, right? Tell me the answer. 6.
6 times 10
6 into 10 to the power minus
3.
3 moles, right? 3 moles. So this is the number of moles of chlorine. And then we usually apply stoichiometry, right? We know the chlorine. So chlorine to sodium hydroxide.
Yes, sir.
Oh, right. Okay, so then chlorine, 0. The ratio is 1:2, right? 0.006 is to X. So then X going to be 0.012 moles. 0.012 moles. But what is this sodium hydroxide moles? What is this mole? In limiting reagent and reagent in excess, there are two types of moles. One is moles added, one is moles needed. Which one is this? This is needed. අපි added එක අමතක කරන්නේ sodium hydroxide. We forgot, we ignored it, right? Simple වැඩි. Right? So then this is the needed moles of sodium hydroxide. Okay? Now we'll find sodium hydroxide added. Sodium hydroxide added. Sodium hydroxide added N equals EV. And then ignore you need to take what you ignore. 0.25 into 38 divided by 1000. So this is your moles. Here look at 2
9.5 times 10 to the power of minus 3.
9.5. 9.5. 0.0095. So this is added. Tell me whether added moles or needed moles. Okay, whether added moles higher or less. This much is needed stoichiometrically. Right? Have we added that amount? No. So you have added less sodium hydroxide. So this is less. Added amount is less. Added amount is less means sodium hydroxide, okay, is limiting. Yeah, limiting or add chlorine is in excess. Chlorine is in excess. මේකේ shortcut එකක් තියෙනවා. පස්සේ කියලා දෙන්න. හරිද? දැන්ම කියලා දෙන්නේ. දැන් මොකද දන්නව shortcut කියලා දුන්නාම ඒක විතරයි ඔළුවේ තියාගන්න. ඒ shortcut එකෙන් හදන්න බැරි වෙන question එකක් දුන්නොත් everyone is in trouble. ඊළඟ paper එකේ revision 4 discussion. Now take the revision 4 paper 2. Take revision 4 paper 2. Revision 4 paper 2. ඊළඟ නියමිත papers ටික අහලා තියෙනවා. හරිද? ඔයගොල්ලෝ complete අපි කියපු විදිහට වැඩ කරනවා නම් ගෙදරදී මේක කරනවා නම් දැන් discuss කරනකොට එන chance එකේ semester exam එකට ලොකු support එකක් එනවා. Right? හැබැයි ඔයාගේ part එක ඔයා කරලා තියෙනවා. Right? يعني ගෙදරදී assignment එක කරලා يعني නියමකට මෙතන යනුජුරු ගාන වැඩක්. Right? Okay, so complete the dot and cross diagram. So don't do the same mistake that I did. Draw over the side. So then complete show electronic structure of one ion, magnesium, I have to show one. This has to be shown. This will not be there because the electrons are given. So there needs 2 plus. And fluorine is going to get 1 electron each. The same story. Have 1 electron and I have to put minus. Don't forget to put 2 in front of fluoride. Right? So the marks, the correct charge is 1 mark. Correct electronic structures 1 mark. And 2, 1. You need to have 2 fluoride ions, otherwise it's wrong. Because fluorine's valence is 1, magnesium's valence is 2. So what's the formula of magnesium fluoride? MgF2, right? And magnesium fluoride doesn't conduct in the solid form. Very important statement in our electrolysis lesson as well, right? But can be done solid magnesium fluoride to make conduct. You have to melt it or dissolve it. Melt it or dissolve. Explain why conducts electricity when it's changed, right? So you can say in solid form, ions cannot move. When melted,
So you're
Sir, we
muted.
can't hear you.
Sir, you are muted.
right? Okay. Thank you, Taylor. Right? It will become again the Dengmot Karana to that. Karla Natilamai. Right. So let's move on. Here another very good bonding question, possible questions with this giant covalent, a simple molecular, they always ask in the exam, right? 1 minute. Thanks. Isn't that it? That's good. So we never knew. Lighting part.
Lighting sponsor.
But then,
Lighting sponsor.
disco light na as දෙක පොඩ්ඩක් වහගන්න. ස්ටෙන්ඩ් එක කරන්න කියලා.
Right, like 100.
දැන් සමහර වෙලාවට දෙක තමයි එකපාරට අලු පාටට right color. All right. The structure of compounds of silicon P and Q are given. So these, I mean, both compounds are from silicon, right? If you are thorough in the syllabus, you will definitely tell this is your silicon dioxide, right? Silicon dioxide is sand, right? I mean, the main constituents of sand, which is giant covalent, right? So this is giant covalent. And this one, they have already given, right? So that this should be silicon tetrafluoride. Now, this is a molecule, isolated molecule. Therefore, if you have another molecule nearby, it's not going to form strong bonds. It's going to form what? Weak forces of attractions. But look at silicon dioxide. It's a giant covalent structure. You have many covalent bonds. Therefore, you have the properties according to that structural things. Okay. Explain in terms of structure and bonding. Structure and bonding. Why compound P has? So you had to say it's giant covalent. Straight away one mark. Giant covalent. Right? Here is the smart answer you can write so that you won't lose any marks. Giant covalent. So many strong covalent bonds need a lot of energy to break. A lot of energy to break. A lot of energy to break. There you answer, right? And compound Q, you say it's simple molecular. Simple molecular. You don't have to write all these stuff, but I'm giving you perfect answers. You can write so then you don't lose any marks, right? Okay, right. And compound Q, simple molecular. So you have weak forces of attractions. Weak forces of attractions. Weak forces of attractions. Right. So they are asking dot and plus diagram for molecule Q, show only the last shell. So let me draw it over here. Silicon has only 4 electrons in the last shell. How do you know? Group number. Group number 4 electrons in the last shell. And chlorine has 7 electrons in the last shell. Group number 7. So this needs 4. This needs 4. And this needs 1. Then silicon will say, okay, so you have to share. The chlorine will say, I can share only 1. Then silicon has to demand, then you come with 4 friends, right? I mean, altogether 4. So then chlorine will share 1. Silicon will share 1. But then there should be 4 chlorine atoms. Anyway, it's there on the board, right? In the structure given, but I'm explaining as if it's not given, right? So you are going to draw the structure like this. So that's the full description about this question, right? So it's just 1 mark because they have given the structure already, right? That's why. If you have made one mistake, like no non-bonded electrons are shown, right, or number of electrons are wrong, number of bonds are wrong, then you lose them all, right? So here we go. Next question. Which term defined by the following term? The average mass of naturally occurring atom of an element on the scale where carbon-12 atom has mass of exactly 12 units, right? Make a by heart karagatta command elamai. This is what you call relative what? This is called relative atomic mass. Relative atomic mass. Right? They never ask calculations from the definition, but they ask the definition. That means the mass of atom. Let's say when you see the periodic table, it says oxygen is 16, right? That 16 was counted comparing it with carbon 12 atoms mass, right? That's why it's called relative atomic mass. In the class I explained this with the puppy and your mass, didn't it? Okay, okay. Let's say you have a puppy. You want to find the mass of puppy. Puppy can find the puppy can find it. So you put the puppy into one side of the balance, right? To the other side of the balance, you are not given kilogram scales, gram scales දීලා නැහැ. Instead of that, you are given apples. මොනවද දීලා තියෙන්නේ? Apples. So you put apples. Then how much the puppy is going to weigh? How many apples do you think?
12 apples.
12 apples. 12 කියලා කියමුකෝ. Why the 12 කියලා කියමු. හරි. So then the mass of puppy, I can say 12 apples. Very good. Why can't you say? But that is not the real mass. What is that? For relative mass of puppy. Why do we find the relative mass of puppy? Because there is no way that we find the real mass. Because kilogram scales are not there. Gram scales are not there. Is that clear? අපි ඉතින් මේකට බිනුක් වගේ දානවා කියන්නේ අපල් කීයක් ඕනද මේ පැත්තට? කීයක් විතර දානවද? අපල් කීයක් විතර can you suggest? 1000. නෑ එහෙම මොම කියන්නේ අපි 100 වගේ දාමු හොඳ නෑනේ. හරි. So 100 apples. Right? එතන බිනුක්ගේ mass එක කීයද? 100 apples. Now, apple එක අයින් කරන්න. apple වචනේ අයින් කරනවා. We know that. So the puppy is going to weigh 12 and Binuk is going to weigh 100. මාව දැන් බලන්න නිකන් 80 වගේ තියෙන්නේ. Okay. So that's what we call relative mass. So in finding the mass of atoms also they are using something like this. ඒකේ apples puppy ලා balance නැහැ. But mass of an atom is measured with relative to something else. And that something else is carbon 12 isotope atom. Right? That's how the definition is. So the main example එකේ carbon 12 isotope atom එක වගේ ඉන්නේ කවුද? Apples. Right? අපිට mass එක කියන්න ඕන the one that we have to tell the mass is the puppy. Right? And the scales are the apples, so then that's the carbon 12. Yes.
So I think අරකට කවුරු වගේ දැම්මත් මේක තමයි වැඩි වෙන කන්සෙප්ට්.
මොකද?
කවුරු වගේ දැම්මත් මේක.
ඒක අපි දන්නේ නැහැ. ඒ අය ඒක.
සෙතෝටි වෙනස් වෙනවා.
ඒ වගේ ඒ දන්නේ නැහැ. එච්චර කොම්ප්ලිකේට් කරන්න ලයින්. හරි. ඔව්. ඕවර් එක අපොල්ලෝ නේ කොට දාන්නේ. හරි. Okay. Explain why the term relative molecular mass can be used for butane but cannot be used to potassium chloride. Most of the time you are not answering this question. Right? You answered. What's your answer? Okay. So the reason is there is nothing wrong. This is relative molecular mass is 58. We find that in the same way. This is 12 into 4 plus 1 into 10 like that. And this is 39 plus chlorine is something like that. Yeah, we normally do by hadane. But why can't you use the word? Because butane, carbon and hydrogen, non-metal. So it is a molecule. Butane is a covalent molecule. They are the molecular mass right? So butane is a covalent molecule. So it is no problem. You call it molecular mass, right? It's a molecule. But potassium fluoride, there are no molecules. Potassium fluoride is what? It's an ionic compound. It's a molecular mass, right? Okay, right? So then you have to say relative formula mass because potassium fluoride is an ionic compound, right? Ionic compound. It doesn't have what? Molecules. Ionic compound. Sorry? No problem. Molecules are all right. Okay. So the sample of city board is very kind. Okay. කියන්න බනේ ඒකත් එහෙමයි නේද? Like 0.095 sample of gaseous Y occupies 60 cm cube and at room temperature and pressure. Determine the number of moles. Okay, room temperature and pressure, volume is given. So that's it. We need V over 24, right? V over 24. So then I can find 60 divided by 1000 divided by 24 because you need everything in dm cube in my calculations. So moles per dm cube. So your answer would be, as you are helping me, 0.0025 or something. Hello? 0.0025 moles. So this is the number of moles. All right. And so we know the moles. Now we know moles. We know moles. N done now. We know the mass. Simple way. So your point relative mass. Easy. N equals M over capital M. Yeah.
Sir, the moles is 1.44. In that one.
60 divided by 24.
No, so 60 divided by 1000. At that also divided by 24, it's 1.44.
ඔයා මොකක් හරි අප්සෙට් එකක් කරගෙන
Sir,
එයා වැඩි කරලා
Sir.
you multiply.
එකම ප්‍රශ්න එකම
No, 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 yeah, multiply. You have multiplied. You have to divide 60 by 24. Okay, and divide it by 1000. All right.
So I did all those things, sir, but still I got 1.44.
මේව කරන්නකො ඉස්සෙල්ලා කැල්ලක් ගන්න 60 divided by 24 ගන්නකො. ගත්තද?
Oh, sir, got that.
කීයද?
2.5.
Then now you divide it by 1000.
Okay, sir.
හරිද? Okay. 0.0025 is equal mass is 0.095 and then the relative molecular mass. And then you cross multiply 0.95 divided by 0.025 නිකන් 38 වගේ නේද?
Yeah.
38. It's not bad. And identify the element. Element which has the molecular mass of 38. Oh. Element. What? It's a gaseous sample of gaseous element. ඔයා කියන්නේ strontium කියලා.
Then divided by 2.
හරිද? Good. And then,
I
okay.
that.
Tenushi? Tenushi? මොකක්ද වටාය මේක?
So I didn't do it.
Nishika?
So is it strontium?
That's the possible answer, even Netuki said. Okay, okay. Initially she said, now she is changing. Lashin?
I'm not sure.
And no, sir, I'm also changing it. It's not the answer.
Yeah, Dolmika?
Sir, fluorine gas.
Sorry?
Sir, fluorine.
Fluorine gas. That's the answer. ඒක නෑ මම මේ කරකවල හැවි අහගන්න ඕන අහගන්න. I'll tell you what's wrong. First of all, you have to be realistic when you're finding answers. Now it's a gas at room temperature and pressure, and you are telling me metals. My goodness. If a metal to be a gas at room temperature and pressure, it should be some other planet like Venus. Not in Earth. Why? Metals are solids at room. So you can't choose one metal here. This should be a molecule. In that molecule, it's an element. right? So what are the gases normally we have? Hydrogen, nitrogen, oxygen, fluorine, chlorine, diatomic gases, right? So who's going to get 38 in the molar mass? It's fluorine because 1990, right? Everything set up into the body. 5 minutes වෙනකම් AC එකක් තියෙනවා. See, right? Okay, so we are facing electricity cut. Just give me 1 minute. Let's connect here. AC එකක්. All right, so we are back in action. I have 84% and right, okay. So then the identity of the element Y is fluorine. Is fluorine. So that's a good question, right? So then this is how we find the identity of molecules, right?
Sir,
Right.
sir, ma'am, our technical is CM cube, sir, DM cube, and sir.
එහෙනම් මේක 24,000 වලින් බෙදන්න ඕන.
Sir, I don't know next.
So you get error carried forward by the way. If this is wrong, make a wrong if you didn't use this DMQ. But you get the mark here. But the problem is with the answer, you get the big number or a small number. You can't decide this. You get it? So then anyway, you get this one up to here, you get 2 marks, but you don't get the mark here. Is that clear? Okay, so far so good. So let's go to the next question. Right. Maybe the last question in this paper, right? Okay. Barium chloride can be prepared by reacting barium carbonate with dilute hydrochloric acid. Okay, just in case, this is what we are going to do if I'm going to get all my power backup is over, right? You will get the today's paper to do timed. Do you get it, students? Today's paper will be on in the assignments. If I, by any chance, I lose all my power before I explain the. Okay. So excess barium carbonate is reacted with 40 cm cube of hydrochloric acid. The percentage yield is given. Calculate the mass of barium chloride present. Give your answer for 3 significant figures. They are asking a lot of things, but giving only 3 marks, very bad, right? Right. So they are giving us HCl, right? And they are asking us to find something about barium chloride. Basically, the percentage yield and the experimental yield is what they are asking for, right? So when you are given percentage yield, you need to know the experimental yield divided by the theoretical yield into 100, right? So this is given, and they are asking the experimental yield. What is missing in that equation in order to find the experimental yield? The percentage yield is given. So what is missing? Theoretical yield. Right? In order to find the theoretical yield, they have given this data. Right? So you can find the moles of barium chloride. You can find the moles of barium, moles of barium chloride by using the moles of HCl. So you use N equals CV. right? Concentration is 1.5, 40 divided by 1000, right? So you will get 0.06 moles. Am I correct? Yeah, 0.06. And then right, 0.06, right? And then you take HCl to barium chloride ratio. 1:2, 0.06 to X. Therefore, the barium chloride moles, am I correct in the ratio? Right, so this should be 2:1, right? So then moles of barium chloride. Moles of barium chloride will be 0.03 moles. Still not. We need to find the theoretical yield, right? Okay. Then I am going to find the mass of barium chloride. Mass of barium chloride will be N equals M over capital M. Mass is equal N into capital M. So mole 0.03. Molar mass of barium chloride have they given? Yes. 208.
6.4.
So this is 6.24. This is your what? Theoretical yield. Then it's done. Why? The percentage yield is given 75%. Experimental yield is the mass of barium chloride actually obtained divided by 6.24 into 100 is your answer. So the experimental yield, you are going to tell me something around 4 something.
4.68.
4.68 grams. So 4.68 grams. Yes. Right. Describe how student can check that all water has been given all. Hydrated, remaining solid is. How do you know all water is gone? You put anhydrous copper sulfate to that. Okay, good method. Kanadi? No idea. Okay. You know? Kanadi? Anyone else? Methu? No. Didn't see the question here. Right? Isara, any idea? No. Let me make question this when hydrated sodium thiosulfate crystals heated. Then මෙතන මේ crystal solid එකක් තියෙන්නේ මෙතුකි. මේ තියෙන්නේ crystals. හරිද? මේ crystal solid එක inside the crystals only you have the water of crystallization. You don't have liquid water. Liquid water නෑ මෙතන. The crystals contain water, but in solid form. It's a very weird form of water. It's there, water is there, but in the crystal form. So it doesn't give any what result for anhydrous substances. Anhydrous substances like cobalt chloride or copper sulfate interact with liquid water. Right? If you have forgotten, just check for test for water. The summer number may water clear in the Hey, you haven't studied those qualitative analysis tests. But don't worry, I'm giving you hint now. So every revision class is a what you call a sign of what you have to study during the next week. Because when I explain something in the revision class, then you feel you don't know this. That indicates, it's an indicator. This is the part you have to study during this week. Exactly. Then water testing, water testing, right? That's how those who are going to win this game are working, right? Okay, you have to work to win. That's no doubt. Okay. So then here you can't use anhydrous copper sulfate, which turns blue when water is there. You can't use anhydrous cobalt chloride, which turns pink when water is there. You can't use both of them here. Because you don't have liquid water, you have just solid crystals which has water inside, right? Okay, now you heat this strongly, and this will turn into anhydrous salt. Anhydrous salt. Now it's a powder basically. It's a powder, right? So now we suspect all water has gone. We assume all water has gone. You have only sodium sulfate, but we have a slight doubt. Has it actually happened? Has all water has gone, right? So how do you know all water has gone? Online students, can you guess any answer?
Sir, I couldn't hear the question, sir. Can you say?
We are in the part one, B part one. I'm asking, how do you tell that all water has gone?
It should have evaporated.
Okay, we can't see that. No, we can't see. How do you assure that all water has gone into this? You have an answer. Sir. Very good. That's the answer. Right? Now, when this happens, the mass of crystals decrease. Right? If all water has gone, you just heat again and recheck the weight. If the weight doesn't change, when you heat it again and then check again, the weight doesn't, the mass doesn't decrease, means all water has gone. Is that clear? So then what you have to do, describe how the student can check that, okay, reheat and reweigh. So recheck the weight. If mass doesn't decrease, all water has gone. All water has gone. You can understand now this is not a thing that you can easily ignore its gravity. There are things that you need to understand. You have to spend a lot of time with this material in order to be thorough with this. I'll give like 1 minute extra for you to write this down. All right, so let's move into the next question. In an experiment, it's a really good question, of course, something that we couldn't do in the theory classes, right? So that's why we are covering everything. Let me come a white madana. Right, okay. But anyway, when the question is asking this stepwise manner, right? It's very easy. You just have to use the correct data. That's it. All right. Okay. So in an experiment, this amount of sodium sulfate heated until all water is gone. Shall I open the windows now if it is hot? Okay. Then we'll done it again. Suddenly I will open. Okay. And then sodium sulfate remained. So then here is the reaction. Sodium sulfate dot XH2O has fully decomposed. I mean, the water part has fully decomposed to give you solid sodium sulfate from crystal sodium sulfate, right? And the whole mass of this is 1.61 gram. And sodium sulfate here is 0.17 grams, right? There is a very important law, okay? By the way, I have two new students in the class. I couldn't say hi for them. Let's say Sahansa is there. New, no? You came this week or last week?
This way.
This way. Risali is there. Risali, can you hear me? Can you hear and see the board clearly? Risali? Am I pronouncing your name correctly? If I'm not, sorry about it. Hello, Risali, can you hear me? Oh, okay. Right. Anyway, you two might be like wondering how these two papers appeared suddenly. These were the last two assignments given in the Microsoft Teams. In the class Microsoft Team login, all right? So you might not have seen the two assignments, but the questions are here, right? But after today's class, you will get used to the class, how it goes. All right, Sansa. But anyway, the discussion, I think you can understand, right? The discussion done, you can understand, right? Okay, right. So let's move on. And there is very important rule in chemistry. There's very important fundamental law in chemistry that you should not forget in all these calculations. What is that? The law of what?
Conservation.
Conservation of what? Yes, conservation of mass. In physics, the conservation of energy. In chemistry, conservation of mass in chemical reactions. Right? Therefore, you have like this compound became these two compounds. So if anything remaining, that should be what? That any other mass that it is not here should be what? Mass of water. Right? So when you subtract these two, this is 0.9, isn't it? 0.9 grams is going to be water. So we know that too. Calculate the number of moles of sodium sulfate remaining. So you had to use 0.71 only. 71 divided by 142. So then it's basically 0.005.
Yeah.
0.005 moles. Calculate the mass of water. Now you can't find the mass of water if you don't know the law, right? But you can even guess. So then it's 0.9. How did you calculate? Anyway, 1.61 minus 0.71, either using common sense or using the conservation of mass, right? So the calculate the moles of water, 0.9 divided by 18, N equals MO. Anyway, I became again fast, no? 0.05. Right, so this is 0.05. And determine X. How do you determine X? How do you determine X? What is the theory of determining X? Stoichiometry, very good. Right? You have to apply what? Stoichiometry, very simple. Stoichiometry between sodium sulfate and water is 1:x. And moles of sodium sulfate here is 0.005. Moles of water is 0.05. And X going to be 10. Therefore, the answer is 10. Common sense on right? But it's very important that you have the confidence to use a theory when they have asked. Or a theory එකක් එනවනම් mind එකට මේකෙන් තමයි ගාන හදන්නේ කියලා. You are on the track of this science. Right? That's what you call like learning science. All right. So I have few minutes to do the MCQ discussion. So I'll do few MCQ discussion of last week paper. Okay, you people have the last week paper with you, right? Take the paper. And I will give the last week paper in the chat for those who didn't have it. So obviously I won't be able to finish the paper 1 revision series for paper 1 today. I won't be able to finish, but that's not going to be a big problem. Okay.
So are you going to give a paper today also?
Yeah.
Oh,
At 7:10. Yeah, at 7:10 the paper will be on. I mean the assignment will be on.
okay, super.
Sorry. 30. Today I'm going to give you 50 minutes. Don't worry. Last day. Other 50 minutes on it there. Because acid base salt no calculations section and I realized it was a failure because not enough time. Maybe you were a little inefficient at the end of the day. If we end up full one day, but again, going to open the connector for this. Today, anyone didn't get the today's paper in advance, right? Is this the paper I have to discuss it? Yes. Okay. So let's move on. Online experience, you can download it from the chat. Right, everything. Which role describe the type of bonding presence in substances 1 and 2? You can't come to any prior decisions. You have to read the answers. Right? Methane has ionic bond. Okay, if you don't know what is methane, that's the end of this question. Right? Methane is CH4, non-metal, covalent. Right? Carbon non-metal, so this is wrong. Graphite, covalent, we all know about it, right? We just learned graphite carbon only. Graphite is ionic bonding wrong, so you don't have to worry about the next one, right? Anyway, it's wrong because potassium chloride is ionic. How do you know? Metal and non-metal, right? And the potassium chloride is ionic. Methane has covalent bonding. That's the answer. The answer is C, right? So you can easily find these bonding type. Just have to remember this, no? Matakada me Venn diagram. Bad luck. I have to advance the paper. Right. Unfortunately, the power backup is over. I will give you the paper now. I'll find some light for you.
So it's CQ1.
Yeah. So මේගොල්ලන්ට paper එක ඉස්සලා දාන්න. Okay, please download the revision series 5 paper. Right now, do it carefully. Both papers are together. I mean, revision paper 4 and revision paper 5 are together in the chat. පස්සේ කියන්න එපා 5 කරන්න තිබ්බ එකේ 4 කරා කියලා දවසම. Right? Can you confirm me in the chat whether you downloaded revision 5? Revision 5. Quickly confirm in the chat.
So the bottom one is the revision paper 5 one, right? Sir? Sir?
Yeah, what did you ask, Nithila?
Sir, the bottom one is the revision paper 5, right?
Name එක බලන්න නිදිලා. Name එක. Check the name, please.
sir.
Yeah,
Sir, how much time do we have left?
I'll put the timer. You have like around 45 minutes.
Okay.
That means 7:45, time is over. I think everyone has enough light. Time is also here.
Sir,
Yeah, Nikhil.
sir. Sir,
Yeah.
sir, are we doing a lesson called titrating calculations in grade 10?
Nitila, you better concentrate on this now rather than asking those questions.
Okay.
Forgot them, If you haven't studied acid-base salt, this paper is going to be very hard. Can't help. But don't worry, we do the same topics twice, right? That is to help you to catch up those things. today when you are returning the grid, return both the grid and the paper. Just in case next week you don't bring the grid paper, then it's useless. No, that's why. If you want to revise the question, the paper is there in the meeting chat. You can get the paper. In approximately 15 minutes, finish the paper. I didn't get your point, Nitin. Okay, you must be submitting the answers now.
So I
I mean,
submitted.
by now it should be done. Yeah. Can you surely bring the paper next day? Huh? Because you can take this over and then start, like, work on it again, right, areas that you have forgotten. Okay. Okay, we are back in action. Take the revision for paper 1. Paper 1. Right, online students, your time up. Please join the class again with the videos on. We'll be discussing the revision for paper 1, the rest of the questions. Right? Hope you guys can see the board. I have only few minutes, but even that few minutes we utilize and finish some questions so that we can do the rest next day, right? No point of like wasting our time. Right, here we have the question number 2. The formula of ammonia is NH3. Its statement about the molecule is there, so then you know NH3 is a covalent compound in which nitrogen has an unbonded 2 electrons as well, right? And so then the bonding in the molecule of ammonia is ionic rho because it's sharing, therefore it's covalent, right? The nitrogen atom has noble gas configuration and hydrogen atoms do not. That's wrong because hydrogen also has full electron like helium. Nitrogen has 8 electrons like the rest of the noble gases like neon and argon, right? So that statement is wrong. The nitrogen atom shares all of its electrons. That's also wrong. It doesn't share these 2 electrons. It shares only 3. There are 6 shared electrons in the molecule of ammonia. That's correct. Therefore, the answer is D. Right? And which structure represents sodium chloride lattice? Now, it looks very complicated and all. They look all the same. But if you look at this, here sodium is minus. That's wrong. Sodium has to be plus. Chlorine can't be plus. Chlorine should be minus. Next one sounds okay. The negative ion is usually bigger because it has a lot of electrons. Therefore, this is wrong. And this is basically a metal, right? So this is wrong. Why I cross these two in the middle? Because they are anyway wrong structures at all. They can't be existing. Last one is a metal, at least. It's not applicable for the question, right? Sodium chloride is ionic. You need positive ions and negative ions. Negative ions are usually bigger, right? Because it has a lot of electrons. Right? Then electricity theory and the videos are joined in the class second. Right. Next. Question number 4. All right, so very similar question we discussed that day as well in the first revision number 3, right? Now X and Y forms covalent compound. All right, if that is a covalent compound, X has to be a non-metal. It can be only one non-metal. What is that? Having 1 electron in the last shell, there's only one non-metal, that is hydrogen. No other metal can be, element can be there. So this has 5 electrons. So that means it's in group 5, something like nitrogen. So basically again, this is ammonia. Okay? Ammonia. So XY3. Which statement about the structural properties of silicon 4 oxide is not correct? You learn silicon 4 oxide is giant covalent. ඇති වෙන්න අහලා තියෙන්නේ නේද? revision කරනකොට ඕක තමයි chance එක, right? Even though you haven't studied, now things go to your head, right? So you have to take the maximum benefit, but you need to have your focus. It has giant structure similar to that of diamond. That is correct. Yes, correct. You are correct. Fourth one, it has to be D. It's not D because its X is hydrogen, right? And NH3, no? So then it's YH3. We all got tricked by this, right? 1000 apologies. The answer is D, right? It has giant structure similar to diamond, correct? Right? It has high melting point due to strong attractive forces between the molecules, wrong. Why no molecules? It's a giant covalent structure. No molecules, right? There are strong covalent bonds between silicon and oxygen, correct? There are no free electrons, fine, that's not a problem. And it does, it's therefore it doesn't conduct electricity, so that's all right. Question number 6. Graphite is a macromolecule, all right. Which statement about graphite are correct? Carbon atoms form four covalent bonds, wrong. In graphite, each carbon atom forms 3 covalent bonds only, right? That's why it is going to have an extra electron to conduct electricity, right? There are free electrons between layer of carbon atoms, correct? Graphite is useful as a lubricant, correct? Good conductor of electricity, yes. Therefore, the answer is 2, 3, 4. Right? Which covalent molecule contains 2 atoms bonded together by exactly 4 shared electrons? Okay, I'm going to remove this question from this because you guys don't know these structures. You don't know the how you don't know how to like bond the atoms there. So this question is removed. Don't worry. Right? Question number 7 is removed. Right? What is the total number of electrons in molecule of ammonia? This is the tricky question. Right? You make it 8, don't you? You mark it 8. No, you don't mark it 8. Super. That means you are good. Now, okay, this is what comes to our head about ammonia. But don't forget, they didn't ask the electrons in the last shell. They asked all the electrons. So nitrogen, basically, it has 7 electrons. It's 2, 5, right? Hydrogen has 1 electron. Therefore, 1 into 3. So in total, we have 10 electrons. 10 electrons. Right? You have 10 electrons. Okay. So now we have discussed 8 questions in the revision series 4. So I have 22 questions more. That means I have like almost done 1/4 of this. Right? I will do the rest of the discussion next day. Sometimes the next day may not be the next revision day. I might call you for like maybe 1 hour online session for the discussion, maybe early in the morning, right? And finish off because I want all the papers that we give to you before the semesters to be completely explained to you, right? As a result, I might organize like maybe half an hour class each, right? Which can cover somewhere around 20 questions and finish, right? For those the remaining few questions. Right, so I'm going to wrap up the meeting. Be prepared for the next day, also the same topics, right? So let me say good night and goodbye to you.
Sir,
Bye.
Sir,
Yeah, Nitila.
the
Nitila?
Wednesday class, sir, is it, sir, at what time, sir, is the Wednesday class?
I will put the message in the night, okay?
Sir, we are doing theory. right?
Probably 11:30.
Okay, sir, we are doing
11:30.
theory. Sir, we are doing theory, right?
Yeah, Wednesday
Ah,
theory, yes. Okay, bye, good night.
Good night, sir. Thank you for teaching.